In this second concrete example, to test our knowledge on p-values and statistical testing, we will take a look at A/B testing. And A/B testing is in fact the most common use case of statistical testing, certainly in industry scenarios. Now, the challenge of A/B testing is to compare a metric between two groups based on small samples. And in a sense, this is the prime example of the central tenet of statistics, getting population insights from sample analysis. And to learn about A/B testing, let's go through an example from start to finish. So let's start our example A/B test by looking at the problem statement. A tech company wants to know whether adding a new feature to their website, and in this case the new feature is an automatically playing video, will increase the time users spend on their website. And thus in this example, this company wants to compare a metric, which in this case is the time users spend on their website, between two scenarios, with a video on their website and without the video on their website. Now they want to know if adding this automatically playing video will increase the time that users spend on their website. Now, if this is the case, then it is worthwhile rolling out this new feature. However, they don't want to roll this out if it doesn't make any difference or not. And that's what you have to investigate and to formulate a conclusive answer about. And to do this, the A/B test can be split up into two parts. The first one is data gathering. Now this part revolves around collecting the right data and building a data set that will allow you to get to a conclusive answer. And then in the second part will be the data analysis, where you take the data that you have collected, do some analysis, which will be a statistical test, and then to formulate the final answer of your A/B test or your analysis. So let's first look at data gathering. Now, of course, what you don't want to do is to roll out this feature to all the users that are using your platform or this website. Because if this automatically playing video makes it so that users actually spend less time on your platform, then of course you made a big mistake in rolling it out to all of the users. Instead, you want to roll out this feature, this automatically playing video on the website, only to a small subset of your user base. And then you want to gather data of how this small subset of users interact and react to this new feature. Now, of course, you also need a comparison dataset. This is a dataset of users that do not see this new feature, so everything remains as old. And then by comparing these two, you can see whether indeed showing this new feature to users increases or decreases the time spent on this website. So in fact, you need two datasets. The first one is the test group to which the new feature is already rolled out. And the second one is the control group, which will serve as the comparison group. In this way, if your feature turns out to be very bad and even makes users leave the website, then this will only be contained to a small subgroup of users. So how do we of course do this in this course? Well, as always, we generate our own data sets. Now in this case, we generated the data in the following way. The test group, which is the subset of people that are shown the new feature, so the automatically playing video, has an average time spent on the website of 16 minutes, and the standard deviation is 2.5 minutes. Now the control group, which is a subset of our user database that doesn't see any change, so everything is the same as before on the website, they have an average time spent on the website of 15 minutes and a standard deviation of 2 minutes. In this particular case, each group consists of 100 data points. Green is the control group and blue is the test group. Now, from only this histogram, of course, you wouldn't want to draw any conclusions because then management will be very cross with you. And then the task you are given now, and the challenge is whether the difference between this average time spent on our website, between the test group 16 minutes and the control group 15 minutes, whether this difference is indeed representative for the overall populations if we were to roll out this feature. And this by now is a very familiar situation that you find yourself in. Namely, you need to figure out whether these sample statistics, in this case a difference of 1 minute, is representative for the population statistics. And of course, that is what we learned in chapter 6, and it calls for statistical testing. Now, before we go to part 2 and dive into the specific statistical tests that you need to perform to get to the conclusion, just a brief remark on this data gathering step. Because if your underlying data on which you will do analysis is not of high quality, because it has some bias in it, then your conclusion will also be wrong and not reflect the actual underlying process. For instance, when gathering your test group, you have to make sure that this is a representative set of all of your user base. For instance, you don't want to only pick out people that got onto your website through a video advertisement, because these people might be already more enticed to look at videos. And therefore, they will not be a representative set, because you might have people visiting your website from other sources. And thus, because your user base of your website is a very diverse group of people, you have to make sure that your sample sets are also diverse. Now, there are many other reasons or phenomena that might influence your data set and that you have to take into account. But of course, that would be too long of a list to go over here at this point. Just keep in mind that your data set that you're working with has to be representative. And if you keep this in mind, then you will get through all of these reasons and make sure that your dataset is fit for a good data analysis. So once you have your data, and once you have the problem very clearly stated, you can go to the second step, which is the data analysis. Now at this point, what we want to test for is whether the difference in means between our two samples, 15 minutes for the test group and 16 minutes for the control group, is indicative for the underlying populations. Meaning, if we would roll out our new feature to the entire user base, will then also the average time spent on our website increase with roughly 1 minute. And thus we need to figure out whether the difference that we found in sample means, 1 minute, is significant or not, and what the likelihood would be if we just find this difference due to pure chance or coincidence. So of course, this we can do with a statistical test. Now, in the previous chapter, we indeed learned how to statistically test for equal means based on sample means. And we saw that in order to get to that test, we needed to perform 2 tests prior to that. Testing for normalcy and testing for equal variances. Now, before we do these tests, we need of course to discuss the statistical significance level. This was a measure for how certain you want to be about your final conclusion. Now, in most cases, we take a statistical significance level of 0.05, meaning that we can be at least 95% certain of our end conclusion. So let's take a p-value of 0.05 as our significance cutoff. So then we start with the testing. The first test is to test for normalcy. This can be done with the Shapiro-Wilk test, and it also returns a p-value. Now, if it returns a p-value larger than 0.05, we can confidently conclude that the populations from which our samples are drawn are likely to be normal, and we can continue to the next step. If this was not the case, then of course we need to go to the alternative tests, the non-parametric tests. But here it will be the case. Then we need to test for equal variances, and this is easily done with the Levene's test. This will also return a p-value which is either larger or lower than 0.05. Then, depending on the outcome of our Levene's test, we test for equal means either by the student's t-test if we have equal variances, or the Welch's t-test if we don't have equal variances. And then the result of this last statistical test will give us our final conclusion, whether this difference in sample means is indeed indicative for a difference in population means and thus significant. Now, before we look at the results of these tests for our specific data sample, a brief note on an independent versus paired dataset. In our specific case, we treated these 2 datasets as independent. We had a control group and a test group, and none of the subjects in each of these 2 groups is part of the other group. They are completely separated. And therefore, to test equal means, we use the independent statistical t-tests. Now, if we were looking at the same group of people before the new feature and after the new feature, then we had to make sure that we were using the paired statistical tests. But that is not the case here, but it's something to keep in mind if you do this analysis on your own dataset. So let's look at the results. So for the Shapiro-Wilk test for normalcy, we had a p-value of 0.82 for sample 1, the test group, and 0.57 for the control group. So both very large p-values, so both samples came from a normal distribution. And we can continue with the parametric tests. Now the Levene's test, which tested for equal variances, gave a p-value of 0.03. Now this is smaller than 0.05, and thus we have to conclude that these two samples, they are representative of populations that have different variances. Remember, if we look at our data gathering step, then we saw that the test group had a variance of 2.5 minutes, whereas the control group had a variance of 2 minutes. And thus now we have concluded that this difference in variances between these two samples is large enough to confidently conclude a similar difference in population variances. That's something to keep in mind and to take away in our final conclusion. Now, because we found through the Levene's test that we have unequal variances for the underlying populations, this means that to test for equal means of the underlying populations, we have to use the Welch's t-test instead of the student t-test. And if we compute the p-value for this test on our samples, we find basically 0. Now this allows us to very confidently conclude that the difference in sample means, 50 minutes compared to 16 minutes, is indeed large enough to extrapolate to the overall populations. And thus we can conclude that introducing this new feature will indeed lead to users spending more time on our website. Now, of course, a data scientist also needs to be able to formulate his or her conclusions in a very clear and concise way, because these conclusions will go to executive levels, to managers, and they are most often not that technical. So our conclusions need to be rephrased in a nice packaged way. Now, before we do that, let's first look at the Python code that actually implements this A/B test. And as we have learned in the last chapter, we will see that this is very straightforward and can be done in just a few lines of code. Now, in this corresponding cell in our Jupyter notebook, all of this is basically just generating our own data set. Now, in real life scenarios, of course, this doesn't need to be done because you'll have a data set given to you. So we can go directly to the tests themselves. So here, these are all the tests and all of the Python code that you will need to perform this A/B test. So first, we perform the Shapiro-Wilk test for both of our samples to check for normalcy. So we simply use stats.shapiro on time of our control group and time of our test group. And then we can print both of these p-values. Now then, we perform the Levene's test because we have indeed normally distributed samples. So the Levene test is again very straightforward, stats.levene, time control and time test. And we can plot the p-value. And then depending on this p-value, we choose a test for testing equal means. In this case, the p-value was very low, 0.03, so we had unequal variances. And therefore, our t-test for equal means will be stats.t-test independent, because we have an independent data set, time control, time test, and equal variances is equal to false, which makes this test the Welch's t-test. And then we can simply print out the p-value of our statistical test, which will yield our result. So if we scroll down, then we indeed see all of our test results right here. And this is how straightforward implementing A/B testing can be using Python code. Now, of course, in real-life scenarios, most of the time will not be spent on the A/B test itself, but more on either formulating the question or getting access to the data and thinking through how to get a representative data set such that it is useful for data analysis. Now, the last step, as I alluded to earlier, is to formulate your conclusion. Now, you could say that the conclusion is very simple, namely that the difference in sample mean is significant. However, then you actually lose some information because we also saw that this variance is also significantly different. Now this means that even though users will indeed spend more time on your platform on average, the spread of this distribution will be larger, meaning that some users will spend a lot more time, but also some users might spend less time. And this is some important information to carry to upper executive levels, because that might be something that they themselves didn't think about, but still want to take with them in making their final decision. And then of course, because they are executive people, which are mostly non-technical, you want to rephrase your conclusion in very clear words and package it in such a way that it is easily digestible. Now, as an example, in the course notes, I wrote a paragraph of how I would package and write this conclusion in a way that I would seem fit to report to executive people. So let's just look at it and let me briefly read it. Adding the feature increases the average time spent on the website with roughly 6.7%, from 15 to 16 minutes, for the experiment that we ran on a subset of 100 visitors. This difference is very unlikely to have come by coincidence and can be considered significant, and thus extrapolated to the entire visitor base. However, adding the feature also increases the difference between how long different visitors spend on the platform, lowering consistency. And this is how I would write it in this specific case. Now, of course, it's always important to include your assumptions if you made any, and include any important information that you think is valuable and has a large influence on your conclusion. And talking about conclusions, this concludes chapter 7, where we looked at 2 concrete examples on p-values and statistical testing. In the next chapter, we will look at correlation, or the relationship between 2 variables in a dataset. It will also be filled with some beautiful simulations and visualizations to really make this concept very intuitive. Now, chapter 8 will be the last chapter of the official course material, excluding of course the bonus chapter, chapter 9, on some preliminary machine learning techniques. So I will see you in chapter 8.